The next lesson is on hyperbolas. Hyperbolas and ellipses share some similar traits, but they also have a lot that are different. So we will explore those in this lesson as well. What is a hyperbola? Well, a hyperbola, remember when we looked at an ellipse, it was the sum of the distances from two fixed points being the same, and it was the set of all of those points. In a hyperbola, it's the difference of the distances from two fixed points. The fixed points we still call focus points. And so what we're looking at is if we have uh, two focus points, in these problems, we always end up making some sort of a box inside of the focus points. And then we find uh, the lines that form the lines that connect the corners. And that's something that happens every time we do these problems. Um, and so what we need to do then is after we do that, we find these things that kind of look like parabolas, and um, they start at the box in a certain direction, and then they follow these dotted lines. So essentially, we end up with these asymptotes formed by the box, and then we have things that look curvy. They're not parabolas, but they kind of look like them if you have no other reference point. And they go in both directions. So that's something that's kind of important. A hyperbola goes in both directions. And so if what you would do is from these focus points, uh, if you took the difference, so that length minus that length, you subtracted the long length from the short length, that would be the same distance at every single point on these blue curves on this hyperbola. So that's something to keep in mind. Also remember in an ellipse, the focus points were inside the vertices. But notice on the hyperbola, the focus points are on the outside and the vertex points are on the inside. So that's an important distinction. Now let's look at the equations of hyperbolas. We have two of them because in a hyperbola, there's a minus sign. So that actually is very important. Remember, in an ellipse, we had one equation, and whether the ellipse was long in the x direction or the y direction was based on whether a or b was bigger. For a hyperbola, a or b's size does not matter in terms of where the hyperbola opens. So that is important. If a is bigger, or if b is bigger, all that does is change the size of the box. So if A is bigger, that means that the box would be longer in the X direction. If B is bigger, that means the box is longer in the Y direction. This has no relevance on the direction of the opening. So if A is bigger or B is bigger, that has no relevance on where the hyperbola opens. So if that has no relevance on where the hyperbola opens, then what does have relevance on where the hyperbola opens? In this situation, since x minus h squared over a squared is the positive term when we solve it and it equals 1, that means that our vertices are going to be in the x direction, our focus points are going to be in the x direction, and our hyperbola opens in the x direction. When we had y minus k squared over b squared as the positive term when it equals 1, that means Our vertex points are in the y direction, our focus points are in the y direction, and our hyperbola opens in the y direction. So if the x term is positive, that means our graph will look like this, where both things are opening left and right. If our y term is positive, it will open where things are going up and down. Let's graph a couple of these problems. So notice that y minus 3 squared is positive. So that means that this is clearly going to open up and down. So that's something that we have to keep in mind when we are finished doing the problem. The center is at 3, -2. That doesn't change in almost any conic section. So the b squared term is 16, so that means b equals 4. The a squared term is 4, so that means a equals 2. So what that means is that our major axis is 8, and it goes in the y direction. So that means I go up 4 and down 4, and that will give me my vertices. Okay. Now, actually, those are only vertices if it opens in the y direction, and in this case, it just so happens to open in the y direction. But these are our vertices. The covertices are always the ones that don't include the hyperbola. So that's a big difference from ellipses. Vertices and ellipses were always the longer ones, and covertices were the shorter ones. In a hyperbola, the vertices are always the ones that include the hyperbola, and the covertices are the ones that don't. So in this case, our covertices are in the x direction. It's shorter, but that's not why they're covertices. It's because it's going to open up and down. So now what we have to do is we're going to take the vertices and covertices and make our box. So we're going to make our box. And then we can draw our asymptote dotted lines. And then our graph is going to open like this. And it's going to follow those dotted lines forever and ever. Now, let's fill out all of the things that you would be expected to fill out. So our vertices in this problem are going to be up and down 4 from the center. So that means they are at 7, -2. No, up and down, Jason. Up and down. So they would be at 3, 2, and 3, -6. And I should be able to see that from the graph. The covertices are going to be left and right. So that means my x is going to change. So it's going to be at 1, -2, and 5, -2, which is clear from the picture. And then we'll talk about focus points in a second. But the other thing we will have to do is we'll have to write the equation of the asymptotes. So the equation of the asymptotes, notice that the asymptotes go through the center point. So we'll write these in point slope form. Y plus 2 equals the slope times x minus 3. So our main job is to figure out what the slope is. Notice there are two slopes because there are two equations. One's going in a positive slope and one's going in a negative slope. So we're going to write y plus 2 equals plus or minus whatever the slope is, x minus 3. And it's really not that hard to figure out what the slope is. So it looks like we're going up 4 over 2. Oh, shocking. Up 4 over 2. So that means if we go up 4 over 2, our slope is 2, or in the other way, it's -2. So those would be the equations of the asymptotes. Finally, we're going to be asked to find where the focus points are. Focus points are always in the direction of the opening, and they're on the outside of the box. And I already drew what we can use to find the focus points. In order to find focus points, we use the Pythagorean theorem. And since the focus is on the outside, our distance from the center to the focus is actually equivalent to this half of the diagonal that we have drawn. So c squared equals a squared plus b squared. So if I draw this a little bit bigger on the outside, the uh, the x radius, if we want to call it that, that's not really a great term for this, but that would be 2 because we had a equals 2, b equals 4 in this problem. And then our job is to find c. So that would be 2 squared plus 4 squared, which is 20. So our focus is the square root of 20, which we can reduce to 2 square root of 5. And so our focus points are in the y direction, so that means the x isn't changing. That's 3. And then we had negative 2, which was our y value of the center, plus or minus 2 square root of 5. So we're going up 2 square root of 5 and down 2 square root of 5 in order to get to our focus points. Focus points always have to be outside the vertices. They have to be outside the box. Okay, y squared minus 9x squared plus 8y plus 36x plus 16 equals 0. Y squared plus 8y plus 16 minus, we're going to factor in a 9 here. So x squared plus, no, that would be minus because we factored out a negative 9. Then we're going to subtract the 16 over and add a couple things. So we're adding 16 and we are subtracting, notice that we have a minus sign, 36. So we have y plus 4 squared minus 9 times x minus 2 squared equals negative 36. Originally, this problem looked like we had a positive y squared and a negative x squared. But if you're careful, you notice that we have a negative 36 over here. And I want to get this to equal 1, so I'm going to divide everything by negative 36. Well, what's going to happen? When I divide everything by negative 36, this is actually going to end up being positive. And this is actually going to end up being negative. So this is really important to understand. So this is actually going to be something that opens left and right, not up and down. So I'm going to divide by negative 36. I get x minus 2 squared over 4 minus y plus 4 squared over 36 equals 1. So let's graph this, and then I will verbally talk about things in order to save time. We have the center at 2, negative 4. Our x direction goes plus or minus 2. Our y direction goes up and down 6. Then we make our box. So in this particular case, notice that even though in the x direction it is a lot smaller, these are the vertices in the problem. So our vertices are at 4, negative 4, and 0, negative 4. And if we wanted to write the covertices, they would be at 2, 2, and at, I believe that is 2, negative 10. So that's kind of important to understand that our vertices are actually the shorter distance in this problem. So let's make our asymptotes. This opens in the x direction. Opens in the x direction. Two more things that we should probably talk about. Where are the equations? Where are the equations of the asymptotes? Or what are the equations of the asymptotes? Well, the center of this was at -4 for the y value and 2 for the x value. So we have y plus 4 equals something times x minus 2. If we figure out what the slope of this is, it goes up 6 over 2. So that means the slope is 3. And remember, there are two different equations there. So one's a positive 3 and one's a negative 3. And then finally, if we wanted to find the focus points, remember that this Pythagorean theorem will give us it. So we have up 6 over 2. That's 6 squared plus 2 squared. That would be square root of 40. Remember, it's going in the x direction. So we have 2 plus or minus the square root of 40. The square root of 40 is 2 square root of 10. And then the y doesn't change, so that's -4. So those would be the focus points. Finally, write the equation of the hyperbola with focus points at 4, -5 and 2, -5, and a vertex at 3, -5. Now, where's the other vertex? Remember, vertices are on the inside of the focus points. The vertex in this problem is 1 to the left of the focus that we were given. So that means the other one's going to be 1 to the right of the focus. Our job is to figure out where this box goes. And we can kind of figure it out, hopefully relatively quickly. The center in this problem is at 1, -5. We can get that by finding the average of the focus points. And so then after we do that, we need to recognize that this distance c is going to be the same as this distance c. Our distance to the focus is 3. This distance here is obviously the same as the distance from the center to the vertex, and that distance is 2. And so our job is to find this distance, which in our problem is b. So that's the distance from the center to the covertex. And we just do the Pythagorean theorem. B squared plus 2 squared equals 3 squared. We will get the square root of 5. So our center is at 1, 5, or I'm sorry, 1, -5. That makes this part relatively easy. Why is the x part first? The x part is first because the focus points and the vertices are all going in the x direction. So that means that our graph is going to open left and right. And now our main objective is to figure out what goes in the denominator of these things. For the x, that's not that bad because we were given that this distance is 2. So because that distance is 2, there's a 4 in the denominator. For the y, this length was square root of 5. So that means square root of 5 squared is 5. So that goes in the denominator there. And we are done.